All right, so I think this is recording. Let's take a look here at this problem. I think originally there was a typo in the problem. So read this problem carefully. Sarah can run at a rate of 12 feet per second. Jenny runs at a rate of 9 feet per second. How many feet of a head start should Sarah give Jenny so that they both finish the 600-foot race at the same time? So I think it said something, like Sarah, Jenny, Sarah. It had the names typed in too much, so there was a typo here. But now I think that you should be able to do this. So identify thing one and thing two, and then press continue. So I'm going to call thing one Sarah. Let's see. Let's take my layer and put it on the top. Yeah. Sarah and Jenny. All right, now fill out the information on distance, rate, and time for thing one and thing two, and then press continue. All right, so Sarah is the faster of the two racers. The units here are in feet per second. And she covers more feet per second than Jenny does. So the faster person is giving the slower person a head start. All right. Now that head start, we need to think in just a moment about what type of a head start she's given her. But let's finish looking at the table and the information. So how many feet of a head start should Sarah give Jenny so they both finish a 600-foot race at the same time? So Sarah is running 600 feet, but not Jenny, because she's telling her to hey, move forward 10 feet or 20 feet or whatever it's going to be. It's 600 feet minus her head start. All right. So we're going to have somebody that says, on your marks, get set, go. And then when they both cross the finish line, we say stop. And that length of time that they ran is the same length of time. Now, I don't know what that is, but I do know that they ran for the same length of time. All right, so there's no information that's given about total type of thing. There's if we add these up, we've got 1200 minus x, but to me it doesn't make sense to look at a total distance. And since they're you're running at the same time simultaneously, I don't think it makes sense to look at the total time. All right. So of these four choices, pick the relationship. Remember that we have distance is equal to rate times time, or solving for time, we have time is equal to distance divided by rate. And so try to pick one of these relationships to explore to set up our equation, and then press continue. All right. So they have not, we've already said that the total type of idea I don't think is going to apply to this problem. Now, if I can't figure something out with the other two choices, maybe I'll come back and rethink that, but I don't believe that I can do anything with that idea that the total is the sum of the parts. All right, distance. They clearly haven't ran the same distance. Sarah is running further because she's given Jenny a head start. But they have ran for the same length of time. So that's the relationship that we're going to explore. All right, and so we know that time is distance divided by rate. So for thing one was Sarah, we want her distance, which she's running the entire race, 600, divided by her rate, which is 12 feet per second. Now, Jenny got a head start. She didn't run the entire 600 feet. Her head start was given in terms of distance, not in terms of time. See, that's another way you can give somebody a head start in two different ways. You could start the race from the same spot, but not both people take off running when they say go. You know, the slower person takes off, and then some length of time, maybe a 10-second head start, and then the second person takes off running to catch up to the first. That's one way you could give somebody a head start is, hey, I'll give you a 10-second head start. The other way you could give somebody a head start, which is the way that Sarah's given Jenny in this problem, is to give somebody, a 10 feet head start or a 20 feet head start to, hey, I'm going to take off from right here, but you go ahead and go up there. And when they say go, take off running towards the finish line. And you don't run the same distance. You give somebody a head start in terms of distance, and that's what we have here. So we've got thing 2 is Jenny, and that distance is 600 minus x divided by her rate of 9. All right, so let's cross multiply. Well, we could reduce this fraction, right? What does it reduce all the way to? I'm a little bit tired this evening. Oh, yeah, 50. Oh, I should have seen that. Huh. 5 times, yeah. All right. 50 and 600 minus x. If we cross multiply, then we have 600 minus x. Let's highlight what I'm doing on a cross multiply. Boy, why does this not like changing pins? Well, I'm cross multiplying here, and I'm cross multiplying there. So I've got 9 times 50. So I have 600 minus x is equal to 450. And if I continue over here off to the side, I'll have 600 minus 450 is equal to x, or that x is equal to 150. So a 150-foot head start. So that's how far the head start that Jenny's getting. Let's see if that kind of makes sense. Now, gosh, will it let me change to an eraser? It will not. I want to erase some of this. There. Sorry this is taking so long. All right. Yeah. So here would be the normal starting line. And that's where Sarah's at. Here's the starting line for the person that's getting a head start in terms of distance. So here we have Jenny. And here is 600 feet away from Jenny. And here is 150. And so to get to 600, here is 450. So when they say on your mark, get set, go, Sarah takes off running, but so does Jenny. They're both running, and because Sarah's faster, she's eventually going to catch up to Jenny, and she does that up here after Sarah has ran 600 feet, but Jenny has only ran 450 feet in that same amount of time. All right, that seems reasonable to me. Ask any questions if you need to, and I will talk to you later. Bye.